Alrighty, this is Tommy Reed. I want to show you a little update on this hydraulic combustion engine. Basically, it uses hydraulics instead of a piston, crankshaft, and piston rod. Basically, we have a 1,000-watt inverter. This is a pump, hydraulic pump that's going to end up pumping up the fluid into the four accumulators, actually five, but this is the combustion chamber. So once that gets going, the pressure is going to rise. It's going to start the system. It's going to start rotating, start generating power. We're also pulling power out from the battery. We do have a battery, so it does start with a 12-volt battery. And basically, I'll just show you what basically it's going to do. This is the ignition. And that basically just fires as a constant. Still working on that. Has to be computer controlled, but let's start this up and I'll show you what it's going to do. So right now I got the power on. So the power is on. Let's turn on the inverter. That's going to have to isolate all my electronics because it really can get really difficult when you're trying to generate power. So right now we pretty much have no RPMs going on. Everything is looking good. And let's start this up. Let's start up the motor. And what we're going to end up doing is building some pressure. And what it's doing is pumping up from the reserve, filling up the accumulator. I can fill up the combustion chamber at the same time. So it's basically 5 accumulators, but this is the combustion chamber itself. So basically it's going to start up. And let's get this up to par. It should be building up. You can hear it building up. You can see my amp, so I'm starting to pull for the motor itself. And here we go. We're about 500, about 400 PSI. It's now revving up. Everything's looking good. I'm not firing it yet. It does have some testing to do. But basically what happens is that with this pressure right now, it's probably about, I would say, probably about 100 PSI. All these chambers are being filled 100 PSI, but also this is the combustion chamber itself. So think of a liquid piston is actually up into this area, already compressed that air and that fuel itself into a chamber. When that detonates, that's going to raise the pressure as high as 800 to even 1,000 PSI. Now, the unique thing about this is that the more it runs, this can actually get up to even higher compressions than diesel engines. So you're talking as high as, I had it as high as 800 PSI. These are 7,000 PSI max containers, so they can handle the pressure, but it gives you a pretty good idea on how that's actually reset when that's actually running. To reset this, because I don't want to drain all these down to zero, this actually goes into a Hero engine or a Rimjet, so that actually goes into this area right here. If I turn it down, you're going to see that the pressure actually is dropping. That's because we're actually running now also a turbine inside. So think of a water jet. We're basically throwing fluid all the way around. This is cooking oil, so everything is biodegradable in this system. There is no liquid fuel. This could run on propane, hydrogen, and other fuels of that nature. And we're running about 558 RPMs right now with a turbine. It's not firing at this time, but right now I'm just getting to everything to control. So this is I have gears in here and just a lot of, it looks good, but looking good does not mean anything. It has to work. So this is basically the first ever, probably ever, purely liquid or hydraulic combustion engine. So we're using hydraulic as a fluid piston. It's all fluid pistons. That's all we're doing. We're not using no crank. We're not using a piston or piston rod. We don't have to worry about any of that breaking. But we also have the advantage of using extremely high compression, higher than diesel itself. So once you get around 300 PSI, you don't even need a spark plug. This spark plug is for the lower pressure. or the lower fuel detonation. So this could actually turn into a diesel effect and much higher than that. So every time it fires, that compression goes up. So I can actually use, if these are up to 500 psi, I can shoot this up to 150 from the motor and then open my port and peak it up to 500 before I detonate. So all that energy then gets stored into the accumulators. And the good thing about this is the greater the load, the more efficient it becomes because it doesn't have to drain as much. The pressure will always stay there. Think of an air tank. So you're not, when this is actually under a tremendous load, it actually works better than actually just running without a load. So that's basically what's going on. So if I close this, it's running on the rim jets also. If I close that, it'll start picking up in speed and get things going. So I can actually shut this down and show you how actually everything is off right now. There's no motor running, no nothing. So you have all that stored energy in the accumulators actually doing work. So then when I restart it or start it back up, I can go from here and pretty much just get the power going in the inverter. And we are producing real power. So this is actually 1,000 watts. It is pulling some of that power from the battery. You can see how my pressure is starting to accelerate. But it brings it back down. So the greater the load, the more efficient it becomes. We already went up to 1,000 RPMs just from that peak. So just imagine getting up to, now listen to this, 3,000 to 4,000 PSI when this combustion chamber runs. And not only that, I only need to fire this 10 times a minute. That's it. Because all that energy is being stored. So when I put this under a load, it actually becomes more restricted and it keeps that energy intact. Think of a, like I said, an air tank. So this is a very unique design. It took lots of years to figure this stuff out with the Clems engine and everything. And I didn't like the idea, well, it was free energy. I don't think there's anything free, but I do think that you can convert one energy into something else, and this is what this does. Now, this is, like I say, a multi-fuel system. It can run on gasification, hydrogen, HHO. HHO is a lot easier, but it doesn't have the kind of kick you want. But one thing about this chamber is this has to always be reset. That means once this fuel is burned, this has to be dumped, and then I have to feed in fresh air, and then I can reset it for the fuel and then redetonating again. So that is pretty much the technology in this. It's a little complex, but it's a lot of hydraulics involved. There is a lot of turbines in here. It's very powerful when you get up to pressure. So the turbine is actually for the torque. So the slower it goes, it actually works even better and it's more efficient. I don't need to run this at 2,000, 3,000 RPMs. It's not necessary. But that gives you a pretty good idea of this. So this is a hydraulic combustion turbine engine generator. Because we do have an alternator in here. Let me see if I can show that off. Let's get a flashlight. There's an alternator. It's a little compact. Actually, it's very compact. You can see the alternator in there. Everything's turning inside, as you can see. So we are producing power. Is it a lot? Not at this moment. I need to get it up to 1,000 RPMs under a load. But once you get it to that point, this is a 240 amp alternator, but I really would rather go with a permanent magnet one because I'm running into a lot of electronics. It's interfering with all the other electronic stuff. So even the ignition, this is a PWM for the ignition system and stuff. This is basically runs my electronics because I have to isolate the DC motor from a lot of things. So this is pretty much the update on this hydraulic combustion turbine engine. Any questions, I'll try to answer as much as I can. And let's turn this off and show you. it actually still wants to run, the more energy it stores. So, Tommy Reed, talk to you later.